Now let's talk about how to find the surface area of prisms that are not rectangular. They generally follow these 5 steps. First, draw and label all the faces. Use the net if it's helpful to you. Then, find the correct dimensions for each face and label them. Then, calculate the area of each face and find the sum of all the faces and label your answer with cubic units. So we'll start off with calculating the area of the bottom rectangular face. So this bottom rectangle has a length of 9 yards and a width of 6 yards. So its area is going to be 9 yards times 6 yards, or 54 square yards. Now we have 2 triangles, the front and the back. They are both equivalent to one another. So we're going to find the area of one of them and then multiply it by 2, since there are 2 triangles that have that equivalent area. So we have 1/2, the base is 6 yards, and the height is 4 yards. So 1/2 of 6 is 3, and 3 times 4 is 12 square yards. And again, this is the area of one triangle. So the area of both triangles will be 12 times 2, or 24 square yards. And now we have the left and right rectangles, because notice that the triangular bases of this triangular prism are isosceles triangles. So these 2 rectangles going on the left and the right are equivalent. So the area of one of them is going to be 9 yards by 5 yards, which is 45 square yards. So the area of the 2 rectangles is going to be 2 times 45, or 90 square yards. And then the total surface area will be the sum of these 3 values. So we have 54 plus 24 plus 90. So we'll have 78 plus 90, which is 168 square yards for the total surface area. And here are the calculations for the areas that we just found. And we did have 90 square yards, 24 square yards, and 54 square yards. And when you add them up, you do get 168 square yards. Notice with the triangles, they put the extra coefficient of 2 in front of the area formula for one of them. You can do that as well. You can also calculate the surface area of this triangular prism using the net. So here's the original diagram, and if we were to unfold it and bring the 2 rectangular sides down and the triangles down front and back, it would look exactly like this. So it clearly shows how we have the bottom or middle rectangle that has dimensions of 6 yards by 9 yards. It shows how you have the 2 triangles, and their base is 6, their height is 4, and you have 2 other rectangles on both sides that are 9 yards by 5 yards. So we can calculate all of these areas and find their sum as well. So let's start with the 2 triangles, which are our 2 bases that we have. So we have 2 triangles, and the area of each one is going to be 1/2. The base is 6 yards, and the height is 4 yards. Well, 1/2 of 2 is 1, or 2 times 1/2 is 1. So we have 6 times 4 remaining, which is 24 square yards. Now we have this middle rectangle. Again, it's 6 yards by 9 yards, which is equal to 54 square yards. And then we have this left rectangle and this right rectangle. They are the same size because, again, we have an isosceles triangle as the base. So we have 2 rectangles, and both of their lengths are 9, and both of their widths are 5. And if we multiply 2 times 9 times 5, we get 90 square yards. And then if we add all of these values up, the total surface area will be 24 plus 54 plus 90, which equals 78 and 90, which is 168 square yards. So we still get the same answer even using the net. And this slide shows the solution to the problem, and the surface area of this triangular prism is indeed 168 square yards. Let's try to find the surface area of another triangular prism. This time we have side lengths or edge lengths of our triangle being 9 centimeters all the way around. So we have an equilateral triangular base, and we have rectangles that are all congruent. Let's get started. So if we look at our 2 bases, they are both equilateral triangles, and the area of a triangle is 1/2 base times height. So we have 1/2. Our base is 9, and our height is 7.8. And since we have this equilateral triangle in the front and in the back, we can multiply this whole formula by 2 to account for both of them in the same formula. So if we do that, the 2 and the 1/2 cancel each other out because 2 times 1/2 is 1. And then if we multiply 9 times 7.8, we're going to get 70.2 square centimeters. Now, if we look at the areas of the rectangles, they all have a length of 11 centimeters and a width of 9 centimeters because it's 9 centimeters over here too, and 9 centimeters across down low. So we have 3 of these rectangles, and their area is 11 times 9. So we have 3 times 99, which is equal to 297 square centimeters. And now, if we add these 2 values together, we will find that the total surface area is 367 2/10 square centimeters. And if we look at the solution found here, it does match what we calculated for the total surface area. We multiplied the area formula of a triangle by 2 since there are 2 triangles, and we found out that the area of the 2 triangles is 70 2/10 square centimeters. And we can find the area of each of these rectangles, which is 99 square centimeters, and we can multiply that by 3 because there are 3 equal or congruent rectangles going all the way around. So the total area of all the rectangles is 297 square centimeters, and if we add these 2 values together, we find that the total surface area is 367 2/10 square centimeters. Now let's try to calculate the surface area of this trapezoidal prism. So we have these dimensions. Let's work on unfolding it or drawing its net to calculate the surface area of it. So if we take this trapezoidal prism and we unfold it, like we take this front piece and fold it upward, same with this back piece, fold it upward, and then unfold the sides going around, the net will look like this. So we have 2 trapezoids and we have 4 rectangles. Or you could look at it as one big rectangle too, your choice. For now, we're going to calculate the area of each smaller shape. So for the trapezoids, we have 2 of them, and the area of each trapezoid will be 1/2 times the sum of the 2 bases, which would be 6 and 12, and then multiply that by the height, which is 4. So then the 2 and the 1/2 cancel each other out. So we have 18 times 4, which will give us 72 square centimeters for the area of both trapezoids together. Now let's look at the bottom rectangle, which is the smaller one over here, and its area would be calculated by multiplying 6 centimeters by 15 centimeters. And when we do that, we will get an area of 90 square centimeters. Now we can do the top rectangle, which is this bigger one. And its dimensions are 12 centimeters by 15 centimeters. And when we multiply these values together, we will get that the area of that top rectangle is 180 square centimeters. And now let's look at the 2 side rectangles. So that's going to be 15 centimeters times 5, and there are 2 of these. So 15 times 5 is 75, and if we multiply that value by 2, we will get 150 square centimeters. And then the surface area would be calculated by adding all of these values up. So we will have 72 plus 90 plus 150 plus 180. And when we add all these values up, we will have a 2 in the ones column, and then 7 and 9 is 16, and 5 more is 21, and 21 and 8 more is 29. So we have 29 sets of 10s, so we have 290, and we'll add up the 1, the 2, and the 1, and we'll have 400. So we have 492 square centimeters for the entire surface area of this trapezoidal prism. And this slide does verify indeed that the surface area of this trapezoidal prism is indeed 492 square centimeters.